Hello everyone, this is Professor Patterns, and in this video, I'm going to be explaining to you exactly how the context window works. Now, it's a very important concept to understand, especially if you're going to be using AI coding tools. Now, imagine that you're on Cline and you ask a very simple question, something like, "Hi, how are you?" Well, when you send this information, what happens is that it gets sent to something like OpenRouter through the API. Now, OpenRouter is going to calculate, well, how many input tokens there are. In this case, the tokens or the words are simply four input words. Hi, how are you? Let's keep it simple. Now, OpenRouter is going to send this information to Claude. Claude's going to receive this, and then it's going to generate some sort of an output. So in this case, the output is I'm functioning well and ready to assist with any development tasks. It sends this back over to OpenRouter, which then calculates, well, what were the output tokens? And then finally, it sends it back to us and displays it on the interface. Now, so far, so good. However, we see here that for some reason, this entire interaction ended up costing us about 4 cents, which is quite expensive. Why did it cost us so much? What happened here? Well, if you take a look at the pricing for the Anthropic Claude 3.5 model, it says that the cost for the input is $3 per 1 million tokens. And the cost for output is $15 per 1 million tokens. What were the input? The input was just, "Hi, how are you?" And what was the output? The output was those 41 words that it gave us. So it was nowhere close to a million tokens. So why did it end up costing it so much of money? Well, initially, when it sent us this message, "Hi, how are you?" it wasn't actually 4 input tokens. Because when we actually take a look at this, it was 10,800 input tokens. It's a huge amount of input, which we can also verify by looking at this over here, 10.8K. So what exactly happened? Well, when we sent our first request, "Hi, how are you?" to OpenRouter through the API, what actually got sent was the task, which is, "Hi, how are you?" but also a bunch of additional metadata. So a lot of different other things like what are the environment details? So what are all of the visible files currently available on VS Code? What are all of the open tabs, all of the scripts that are open? What's the current time? What's the current working directory? What's the current context window usage? And is it on act mode or is it on plan mode? Not only this, it also sends other things like the system prompt, maybe all of the different tools that it has access to. So a huge amount of data actually gets sent in this API. It's not just a simple "Hi, how are you?" Now, in terms of the output, it does make sense. The output is 108 tokens back, which if you take a look over here, this task completed was "I'm functioning well and ready to assist," but there's also some other stuff like, since this is a greeting conversation, I should respond directly and professionally. So the output and everything makes sense. The input was a little bit confusing. Why it ended up costing us so many tokens initially? Well, it makes sense because it does need to send all of this information to Claude so that Claude has some context when it's providing a response. It understands, well, all of the different tools that it has available. It can open up a script, it can write some code, it can edit some code. It has all of those abilities. And we need to be able to provide those information to Claude, which is why the amount of tokens goes up so much. Now, if we take a look over here, we have something that's known as the context window. And so far, based on the input and the output, we filled up about 10.9K tokens from our 200K token context window. Now, different models have a different context window. You can kind of think about context window as just the memory of a large language model. So, for example, Google Gemini 2.0 Flash has a 1 million context window. The OpenAI GPT-4o Mini has a 128,000 context window. And then the DeepSeek V3 model has a 164K context window. Now, it's not necessary that the larger the context, the better the model. No, it just means that these models are able to process with a large context. However, I have seen from firsthand experience that once we get to a point where we go past 200, 300K tokens in the overall context, most of these models do seem to start performing a little bit less than desired. Now, Let's go back to our original example, which is, hi, how are you? We send that to OpenRouter. Claude gave us a response back. We can keep this simple, say that this was 10.9K context, and then just call this input 1 and output 1. Now, here's the thing. All of this interaction was within the same task. So say that now we ask something follow up within the same task. Maybe we give a follow up question, something like, can you do X for me? Well, that is now going to add more to the overall context. So we ask the model now to maybe create a simple Python script, and then the model is going to respond with some sort of a Python script, and that's going to fill up the context. Now, the more information that we provide within the same task is going to keep constantly filling in the context. And then we get to a point where the context is as close to 200,000 as possible. And usually when we get to about 60, 70% of the context window, we do start seeing some deterioration in the overall performance of the model. So what happens when you end up with a context window that's extremely large? Well, the easiest thing that you can do is simply create a new task that's going to completely reset the context. So let's go ahead and see this in action. I'm going to start by asking Cline to create a completely new script and name it based on what it does. The script should take in a list as an input and then multiply every element in the list by 2. So this is the task that I've assigned. Now you can see over here, it first starts by sending an API request. So the task, the environment variables, so it says VS Code visible files and there are no visible files, what all of the open tabs are, what the current time is, and also what the current directory and the context window usage is as well. Now, based on all of this information, it says I'll create a Python script that's going to return this. There's a main function that takes a list as an input, error handling, and a test case for demonstrating usage. So it's created this new file and then wants to execute the command. I'm going to reject the execution of the command and have it complete the task over here. And there we go. So now that the task is complete, we should be able to now see what the total amount of token cost there was. So we had 271 as the output token. So all of this that we have over here contributed to the output. In terms of the input, we had 24.6K input tokens that went in. Like I said before, the API request, it does have a huge amount of input tokens. And we also have, so every time we send in the API request, we do end up sending a huge amount of tokens, but it's not really a huge deal because the output tokens is actually 5 times more expensive than the input. Remember that the input was $3 per 1 million versus the output, which was $15 per million. So that's the thing that you want to keep in mind. The output tokens should not be significantly large. Now let's try to add over here the same exact information that I provided before, except this time I'm going to ask to multiply every element in the list by 4 instead of 2. So what's going to happen? Now, again, it's going to send the API request in. It's creating a new file, and we can see over here that in the API request, it does include the VS Code open tabs, so the list multiplier tab. So this is the one that it picked up on. So that's great. It also looks at the current context window usage. So it's 6% of it was used. So 12,598 tokens. Now, after executing this, now the context window went up to 14.1K tokens. The total amount, notice that this is not every single time that we send this. This details the total amount of tokens as an input and the total amount of output tokens. So it's a cumulative sum over here. So this is the final information that I provided over here. So it doesn't matter. We can keep having more and more tasks like this over here. We can say multiply every element in the list by 15. And we will see that this in general is not going to be filling in a huge amount of context. Sure, the input and the output tokens, it does end up filling up quite a bit, but it's going to be quite slow to fill in the overall context because these are very similar tasks that we're asking it to do, simply just one-off scripts that it needs to create. So that's fine. Here again, after executing the script over here, we will see that the overall context window is now just 15.7K. So not a huge deal by any means. We have a limit of 200K tokens. What if now within this task, for some reason, we decided that we now want to create a HTML, CSS portfolio website. And let me just say that this is a simple HTML, CSS portfolio website. Well, now when we send the API request in, we are saying that the user provided feedback. It said that they want to, or I guess the task here is to create a simple HTML CSS portfolio website. It gave all of the environment details, all the current open tabs, as well as the current time and the context window usage. It knows that it's currently in act mode, and we see here that we go from 15,600 context window now to 16.7K as the overall context by writing all of the HTML code. And let's see also how much the CSS also ends up filling in for the overall context. There we go. After filling in the style.css, we could see that the context window did jump up quite a bit now to 19.1K. So it really depends on the type of task that you are providing. The more varied the task, the more different the tasks are, the more this context window is really going to start filling up. Now imagine that I create a completely new task, right? So let's cancel this and then create a new one. And over here, I'm just going to say something like the same exact thing that I had before, but this time I have it multiply everything by 4. Well, when it sends the API request in, it does keep track of all of the things that it opened up before. It also keeps track of all of the things in the current working directory. Now, in this case, the context window is 0. So it completely reset our context window, which is great because once we start getting to a larger context window, say like 70, 80% usage, the overall performance does start to drop quite a bit. So in this case, 12.2K tokens went out. 70 tokens came in from the large language model. So that's great. So we were able to see this script over here populate. So that is the overall idea behind the context window. Now, in future lessons, we are going to be covering more detailed strategies, not just simply creating a new task, but also how if we do get to a point where one task context window is really starting to fill up, what are some other strategies that we could potentially implement that actually will save the state of all of the things that it did in that particular task, maybe in some sort of a memory bank. But in this video, I just wanted to cover some basic ideas, some basic concepts behind the input, the output tokens, and the overall context window. Thank you all for tuning in, and I'll see you in the next one. Goodbye.